Unit 1, Lesson 1, instructional video. What is an undefined term? In geometry, definitions are formed using known words or terms to describe a new word. There are three words in geometry that are not formally defined. They are point, line, and plane. Notation. When we're talking about notation, notation is what you would do to name something. How do you name or write about points, lines, planes, and so forth? So this particular example is asking you to name 2 points on the top face of the cube. There are several. To name a point, we need the word point and a capital letter that you are referring to. So the top of the cube has point D, point C, point H, point B, and point A. Referring to lines, there are several lines drawn on this cube, and I'm asking that you name each colored line. When talking about lines, we need 2 capital letters. For instance, the blue line is line BD with the line symbol over top. It can be reversed as well. Lines go on forever, infinitely in both directions, and we only need a minimum of 2 points to create them. Thus, we need 2 points when naming them. The green line goes between point A and G, infinitely in both directions. The red line, points E and F, again, infinitely in both directions. The black line has no letters on it other than the lowercase letter L. The purpose of that is that lines require a minimum of 2 points in order to be established. However, lines are created from infinitely many points. Having that been said, we can use the lowercase letter as a simple notation to refer to something without necessarily needing any of the points on the line. And lastly, the yellow line, which I'm going to use purple for this one. When naming this yellow line, students always want to call it CHB or any combination thereof. However, when dealing with lines, look at the patterns that you have set for yourself in all of these. You have 1 capital letter, 2 capital letters. Those capital letters show where the line is traveling. This particular line is going from B out to C, infinitely in both directions. You could also call it, if you wanted to, BH, because it is describing the same path from B to H, infinitely in both directions. Likewise, you could call it, sorry I'm out of space, we could call it CH or the reverse as well. Because again, even though there are 3 points on the line, 2 is the bare minimum to let us know which line you're talking about, because it can be extended. Collinear. Collinear is when 2 or more points lie on the same line. So I'm asking here, are A and B collinear? Find A, find B. Yes, A and B are collinear because they are on the same edge. For the next one, I'm asking, are D and F collinear? Most of my students have said, no, D and F are not collinear, but in reality they are. In order to talk about any line, you need 1 capital letter, 2 capital letters, and if you were to start at D and come out towards F, think about piercing the cube, you'd be able to make it through the cube in a straight line. So yes, D and F are collinear. They could lie on the same line. How about D, A, and F? When you look at it 2-dimensionally, many people are tempted to say yes. However, here the answer is no. If you have a cube or the paper cube you created in class, grab it and look at it. Picture putting something through D and having it come out F. Really, A is on the front face of the cube. So while it looks like my drawn line is going to go through A is technically on the front face of the cube, while the line is going behind point A. Lastly, D, A, and C are not collinear. they couldn't possibly be, as C is up in the corner. And I think there's one more that I don't have on my screen. B, H, C, are those collinear? B, I gotta erase. B, H, C, are they collinear? Absolutely. Name the faces of the cube. There are 6 faces to the cube, and when we discuss naming them, they are planes. Planes always get named with the word plane, followed by 3 non-collinear points. Non-collinear refers to the idea that these points do not lie on the same line. So let's look at the top of this cube. I need the word plane, and I need 3 points that are not on the same line. For instance, D, C, B. If you look at plane D, C, B, by discussing DC, you have length. By using the point B or anything else on the top of that cube, you've now given yourself width. So we have length and width, which gives us the plane. Looking at the right side of the cube, I'm going to use the points C and B again. But I need a third point. If you noticed on the top, I had point D. So I had length and I had width. When we talk about the right side of the cube, if I were to call it plane CB, by calling it plane CBG or even CBF, you've now made your eyes go back from this line straight down to let somebody realize that if you start with BC on that edge, that you're going down and not across. So call it CBG, call it CBF, or any combination of those letters, but you need 3 points that do not lie on the same line. The back of the cube. Again, I'm going to use the word plane so that everyone knows what I'm talking about, and I need 3 points that do not lie on the same line. Here, I'm going to use D, C, G. DC brings your eyes across the back. Calling it G allows you to go down to recognize that there is a plane back here. D, C, G. Talking about the bottom of the cube. If you look at your paper compared to my screen, I added a capital letter M at the bottom. The purpose of the capital letter M is so that I can name it without having 3 different points. The left side, there's not enough information, happens sometimes. And then the front, there are 4 points on the front of that cube, but you only need 3 of them. I'm going to call it A, B. And for the third point, if I call it AB, you recognize that you're going side to side. So whether you want to call it ABF or want to call it ABE, you're still, by using one of those 2 points, bringing your line of sight down as opposed to any other direction. So ABF. Intersections. Intersection is where things meet. Your vocab talked about where lines meet. Here, though, we're talking about planes. Name 2 planes that intersect at BC. Line BC is here. It's our yellow line. So which planes helped us form that? The top plane formed it, as did the right plane. So the top and the right, but I want us to name them appropriately. So to call the top plane, and I need 3 letters, I'm going to call it A, B, H. Notice I used different letters than I did on the previous slide, but it's still going from A to B. You have length. Calling it H brings your eyesight back so that you know which plane you're talking about. For the right side, I'm going to call it F, G, C. Whoop, I need the word plane in front. I've again called it using different letters, but I need a minimum of 3. F, C, G is allowing anybody to follow their eyes and say, to recognize which side of the cube you're referring to. Coplanar. Coplanar is points or lines that lie on the same plane. R, D, A, B, F, coplanar, no. D, A, and B are on the top of the cube. F is not. How about the points D, A, B, H? Yes, they are coplanar. They all live on the top of the cube. And lastly, I've given you 3 points here. D, B, and F. Most of my students say that no, those are not coplanar because 2 are on the top and 1 is not. However, think about what you need in order to make a plane. I said you needed the word plane, 3 capital letters, and they needed to be non-collinear, meaning not lying on a line. If you look at D, B, and F, there are 1, 2, 3 letters, so we meet that stipulation. They do not lie on the same line, so technically they could create a plane. Think about this for a moment. If you had a cube and you were swinging an axe down at it, you would have a rectangle if you were to open up the inside of the cube. Look at this graphic. Here in yellow it shows the plane that could be formed by points D, B, and F. So yes, through any 3 non-collinear points, there is exactly 1 plane. Naming the intersections. When I posed this problem to my students in class, a lot of them were confused as to what I was asking. In blue it says name the intersection of line DB and line CB. What if I were to say where do line DB and where do line CB cross? Where is their intersection? Name it. DB is here. CB is here. So when I say name the intersection, I want to know where do they intersect? How? Well, 2 lines intersect at a point. These intersect at point B. So we need to know how to name points so that we could answer that question appropriately. Name the intersection of line CD and line BH. Thinking about a line that it will continue forever, so the intersection will be point C. Lastly, name the intersection of line DC and line AB. These have no intersection. And the reason why is because lines CD is parallel to line AB. The reason why the notation is so important for this particular unit is think about all the words I just used. Line DC is parallel to line AB, but I didn't write anywhere near that number of words, and that's what the notation allows, is for us to write the meanings of words without needing to write all of the words. All right, a postulate. A postulate is a true statement which is not required to be proved. Postulate is used to derive other logical arguments or to solve a problem. They are also referred to as axioms. Here, the first bullet point is adequate enough to write. There are 4 basic postulates to geometry. They are the following. Through any 2 points, there's exactly 1 line. It is for this reason that when we name a line, we only need 2 points. It's the bare minimum. Through any 3 non-collinear points, there's exactly 1 plane. Again, why we need 3 non-collinear points to name a plane. If 2 lines intersect, they intersect exactly at 1 point. And if 2 planes intersect, they do so at exactly 1 line. So let me draw you some quick diagrams. Through any 2 points, there is a line. 3 non-collinear points make a plane. 2 lines intersect at a single point. And 2 planes, think about the top of your cube, intersect at a line, and I can use a lowercase to describe it. Please do the best you can to fill out your notes. Let me know if you have any questions.